So far in Haskell, we've defined basic input-output operations by defining a main method and then just carrying out some basic stuff using do's, ifs, and some basic input-output operations like getLine, getChar, that sort of thing. Today, what I want to have a look at is how we define a simple version of Hangman, which if you've never played the Hangman game, essentially what you do is you're given a string, or you give it a string, and that is then hidden, and the user has to guess that with the correct letters that they guess being revealed to them. Now this isn't going to be exactly Hangman, it's just going to be a simple version. It's going to make life a little bit easier for us to code. But essentially what we want to do is take a string from the user, hide that from them, which will be quite difficult, but we'll see how to do that. So we want to hide that string from them, take guesses from them, and if their guess matches the word, then we tell them, otherwise we reveal parts of the word to them. So, first things first, we have to define silent getLine. So this is, getLine is the input-output operation that takes a string from a user and terminates when they hit enter. Silent getLine will do the same thing, but it will not echo to the terminal. Now if you're not aware of what echoing is, that's like when we do, say, let's say, getChar, we hit enter, we have to give it a character, say I give G, then it echoes back what I give. And same with getLine. If I hit this, so I mash the keys and hit enter, it will return that string to me. So I need to define a silent version of this because I don't want the user to see what the word is straight away. I want to be able to give a word that's hidden and then they have to guess. We also then have to define the play function, which takes a string. And you see this is the word that's gotten from getLine. The word is given to play. And that will allow us to recursively guess what the word is. So before we do any of the complicated input-output stuff, first let's define something that allows us to guess what the word is. So what I want to do is we guess a word, and then we compare that to the word that we're trying to guess, and we reveal the characters that have been guessed correctly. So let's see how we would do that. So we take an X's and a Y's, and this is going to be a list comprehension. First of all, we're going to take each element from X's. So because a string is a list, we can take elements from it as we would any other generator. And then what I want to say is if X ln of Y's, then X else. So we return a string where if the letters match up or the characters match up at certain positions, we reveal them. If not, if they don't match up, then we return a little dash that keeps the letter hidden. So this will be useful for us later on, but this is the first thing that we're defining just to get that out of the way. Now we'll worry about the input-output stuff. So now, the way that we should tackle silent getLine, I would say, is we want to take in a character at a time. If the user hits enter or /n for new line, then we want to terminate and return the string that we've gotten so far. We don't want to print it to the console, but we want to return it so that it can be worked with. If not, then what we do is we take in one value, one character that's just been given to us, and we recurse, building up a list as we go. So the problem with this is we then need a version of getCharacter which does not echo to the terminal. So let's define that. And this is why we've got this import system.io here. Some of the stuff today that we're going to do, you're not going to have to do by yourself. Fiddling about with stuff like echoes is a little bit tricky, so I wouldn't make you do that yourself. So don't worry if you don't necessarily get that. You won't have to do that by yourself. And if you do, you'll be given plenty of support with it. So what we want to do is use hset echo. And this takes something called a handle. This will be std in. And we want to say false. So essentially, you don't necessarily need to worry about this hset echo or std in. Essentially what we're saying here is set the echo to be off, and that's it. That's all you need to take from that line. And then what we'll do is we'll do x comes from getChar. Now that the echo has been turned off, I can use getCharacter itself to get us the value in from the user. And then we'll use hset echo standard in, and we'll set that back to true. Because we want to be able to echo at some point, we just don't want to when we're getting the character in. So we just turn it off, get a character, and then turn it back on again. And then we return X, because that's the character we're interested in. So that's the silent getCharacter. Now I could save this and run this, but this play word and getLine haven't been defined yet, so we get errors. So let's worry about doing getLine next. And this is going to be equal to do And I was going to say we check character by character, building up a list as we go. So we'll do x comes from get ch. And then what we want to do is say, is this equal to /n? That's a character that represents a new line. So if it's equal to that, then we want to terminate and return what we have. So if /n, and then we want to put that character to output. So we want to print out a little line just so that we get a bit of a neater output. Not x, it's x. And then we want to return the empty list. Because this is the case where I've finished taking in the string, I don't need to build up a list anymore, so I will return the empty list. If this confuses you, you can just think about this like any other list-based function that we've done where the empty list has been the base case. This is the case where we've gotten the final character, or the character that denotes the end of the string, so we just return the empty list so that we can build it up recursively. But it'll make a little sense when we see how we would do this. So we'll do else. What we want to do is put car x, and then, oh no, we don't want to put car x, actually we want to put car, I'm getting ahead of myself. We want to do put car and put the dash out so the user doesn't see what the character was. And then we want to do x's comes from sGetLine. So we recurse so that we can build up the rest of the list. And then we return x cons x's. So you can see here this is taking more of the shape of what we would expect from something like a list function. So here, with the recursive call builds up x's, and we just stick x onto the front of that list. So you could think of this, if this was a one element list where we just get one character in, say someone gives us an A or something, we come in, it does not equal this, so we do put car, and then we recurse, saying get line, the user hits enter, and that gives us a /n, we return the empty list. So here, when we try and return this, x's is defined as the empty list, so we return A in a single element list, in the singleton list. So that's silent get line and get car. So now we want to define play. So play for some word is going to be equal to do, and I'm going to do this for the sake of the user's sanity, where we do put car and we put out, actually let's put str question mark. This is just to change the prompt. So in the same way that we have main for prompt to let us know that the computer is waiting for our input, we'll put in the question mark so that the user knows it's their turn to guess. And then we'll do guess equals, or actually no, it comes from get line. So here we don't really mind if it echoes to the terminal because this is the user's guess, so they know what they've guessed, and this will give them a little bit of a hand in guessing what the actual word is. So we get their guess from them, and we want to say if guess equals word, then we'll just put some string to the terminal saying like that. Else, what we want to do is we want to put string line. We want an end to the sentence, so we want it to hit enter at the end of it, and we want to return match. And I think the way that this should be is word and guess, and that will return the list made up by the function match with the dashes and the letters that they didn't get and the words revealed that they did get. And then we just want to recurse using word. So we don't update the value of word because that's what's assigned to us at the start of the game. So let's save this, reload. It's all happy days. So let's do Hangman, and let's say I do something like Haskell, hit enter. So you can see here that this printing of the dash is to show that I'm actually typing something into the terminal. So Haskell is, or the code that we've written is just reassuring us that the code is still working, it's not frozen. People don't like it when you just have to enter things and you can't see anything being typed in. So we've guessed Haskell, so let's say we guess ask, then we get part of the word revealed to us. If we just mash some keys, hit enter, we get some of the keys that were correct, or some of the characters that were correct revealed to us, but not all of them. So then we can guess Haskell, and we've got it. So that's a simple version of the Hangman game. You can see that we built up our functionality slowly but surely, and by doing that we could get a bit more, or make our code a bit more readable. You also, again, just to reiterate, you don't really need to know what this hset echo and stdin is doing. This is just something that we're using to make this example run. You don't have to remember these functions unless if you're supplied with them, then you will also get an explanation of what they do and how they work. So don't worry too much about that. But I just wanted to show you how you can quite easily and quite quickly build up functionality in Haskell. But that's everything for today. As I say, if you want another explanation of this, you can find a version of it in Graham Hutton's book, or Richard Bird's. As I say, Richard Bird's is a little bit out of date, but it's still got some good description around it. But that's everything for today. I hope you found this useful. Of course, if you have any questions, feel free to get in touch. Thanks.